Good morning and welcome back to Dr. Logic Awkwardly Does Logic with Pikachu by special request. Today I want to talk about some of the limitations of propositional logic. Now, we motivated it by looking at the syllogistic and seeing all of the things that we would like to be able to express that we weren't able to express. So we followed the Stoics who looked at Aristotle and were like, but there's plenty of good arguments that you can have that just don't involve this term language, this categorical syllogism, categorical proposition construction at all. But we may have gone too far in our movement away from the syllogism by looking at purely propositional structures. So what I'm going to do is I'm going to bring up a bunch of sentences that seem like perfectly reasonable, perfectly ordinary sentences that maybe don't get represented in propositional logic quite the way that we might want them. So I was clever and I wrote them up in advance. So there they all are. Brilliant. So consider these sentences. Every number is either even or odd. For every number, there is a larger number. Neffy is more shouty than Goldie. If the table is brown, then it is wood, because all brown things are wood. No book is red, Socrates is mortal, and the biggest book on my shelf has a lot of pictures in it. Now, some of these sentences are true, some of them are false, but with the exception of the one about the table being brown and wood things being brown, none of them actually involve any propositional connectives. Well, wait a minute. Let's take a look at the first one. So that one has a disjunction in it. It even has either or. So you might think, okay, well, if we were going to render these sentences in propositional logic, well, at least that one has a complex structure to it. But if you think about it, how would you render every number is either even or odd? What is the disjunction between? The thing that you might be inclined to do is say, well, it's a disjunction between the sentences either every number is even or every number is odd. But if you know anything about mathematics, you will recognize that the sentence I have written up on the whiteboard is true, but the one that I just paraphrased it as is not. So it's true that every number is either even or odd, but it is not true that either every number is even or every number is odd. But so that's one problem. There is this sort of like propositional like looking structure in that sentence, but there isn't actually any obvious or straightforward way of rendering that sentence in propositional logic. But look at some of the other things that we have here. So a lot of these are just basic categorical propositions, such as no book is read or Socrates is mortal. Well, remember what we said about our term language being kind of very narrow and very persnickety and not allowing proper names. But still, if we want to say Socrates is mortal, this seems like a perfectly reasonable sentence and something that we might want to be able to represent. But there's other bits. So not just the fact that we've got proper names or kind of propositional structure within our sentences, but we've got things like definite descriptions. The biggest book on my shelf. How do we render that? We couldn't do it in the syllogistic, but we can't do it in propositional logic either, unless we want to take that final sentence as just like one propositional atom and ignore the internal structure. What about the second and third sentences? So for every number, there is a larger number, or Neffy is more shouty than Goldie. These express comparatives or relations. So you can take two numbers and you can say this number is bigger than this other number. And that isn't saying something at the level of kind of propositional structure. It's saying something about the relationship between objects. And that is the key, kind of the key insight that I want you guys to get. What these sentences are talking about is they're talking about properties of objects. Sometimes individual objects like individual cats or individual books or individual people. Sometimes general things about objects like tables in general, numbers in general, books in general. And some of these things were the sorts of stuff that we could do in term logic. No book is read. Some of the things involve bits that we could do in propositional logic. So the fourth sentence, if the table is brown, call it P. Then it is wood, call it Q. Because all brown things are wood, call it R. It has propositional structure, but the point is it also has more. So if we rendered that sentence just as if P then Q and R, because is basically just a conjunction from the point of view of propositional logic, we completely miss out the fact that R is intended to be giving a reason that explains why if P then Q is true. So there's something about the structure of the atoms. So basically, what I would like you to kind of see is that term logic got some things right. It had notions of quantification. It had notions of kind of attaching, predicating terms of other terms. Propositional logic, again, got some of the things right. We still want to be able to talk about conjunction, disjunction, negation, implication, all of these things. But put these all together, and there are things that you could say if you combine these two approaches that you can't say in either one alone. And that is what we're going to be doing with predicate logic. Predicate logic takes as basic objects and properties of objects and allows us to make statements about individual objects having certain properties, such as the individual Socrates having the property of being mortal. We can talk about classes of objects having or not having certain properties, such as no book is read or every book is read. We will also be able to talk about comparatives and relations. So this number is bigger than that number. This person is taller than that person. We can also do, and other relations that are not necessarily comparatives, such as John is the father of Mary, or my microphone sits to the right of my laptop, which is actually false because it's sitting to my left. But you can also do more complex relationships, such as, I'm just going to use X's and Y's because it's easier. X is between Y and Z. So you can talk about three-place relations, or even more and more and more and more complex relations. Though generally, you don't really have many of those kind of more complex relations in the English language. So it's a point where kind of like logic can say more than we actually end up saying in English. So this is just a bunch of motivation to kind of get you to see that there are things that we would like to be able to express that we can't do in the term logic, and that led us to propositional logic. But there are things that we can't express in purely propositional logic where it's kind of like, well, but we'd like to have the properties and the predication and the quantification that we had in the term system. Well, if we put the two together, we get predicate logic, which is basically the most expressive and robust logical language that you could possibly want. I mean, there are other extensions and things that you can do to make it even more fancy, but predicate logic, also called first order logic, also called quantifier logic, is basically kind of the root logic that underlies everything else that we do. So that's what we'll start talking about next in the next videos. Again, same system that we've done with our other logical systems. We will define a language, we will look at semantics, and then we'll move on to proof theory. And then we'll say kind of some meta-language results linking up the proof theory to the semantics in the same way that we did for the propositional logic case. So I hope you're looking forward to it. Join me, possibly also Pikachu next time. I look forward to seeing you then. Cheers.